Have you ever gazed at the night sky and wondered if there's life beyond our planet? This is an existential question that has piqued our collective curiosity for centuries. As we look up at the stars, we can't help but wonder if there are other worlds out there, beyond the confines of our solar system, that harbor life. This curiosity has led us on a remarkable quest, the search for habitable exoplanets. These are planets outside our solar system, far away in distant galaxies that we believe could potentially host life as we know it. We've been using advanced telescopes and scientific instruments to scour the cosmos, hoping to find these elusive worlds. And while we've made significant strides, the quest is far from over. It's a journey that continues to intrigue us, challenge us, and inspire us. As we venture further into the cosmos, the question remains, are we alone in the universe? The quest for habitable exoplanets is not a recent endeavor. The idea that other stars might host planets has been around for centuries, but it was only in the 20th century that astronomers began to develop methods to detect these distant worlds. Early attempts to find exoplanets often involved looking for wobbles in a star's motion, a method known as Doppler spectroscopy. These wobbles could be caused by the gravitational pull of an orbiting planet, but detecting such subtle movements required incredibly sensitive instruments. The first confirmed discovery of an exoplanet didn't come until 1992. Astronomers Alexander Wolszczan and Dale Frail announced the discovery of two planets orbiting a pulsar, a rapidly rotating neutron star. These planets, named Poltergeist and Phobator, were the first definitive proof of the existence of planets outside our solar system. However, as they orbited a pulsar, rather than a star like our Sun, they were unlikely to be habitable. The concept of the habitable zone, or the Goldilocks zone, emerged as a crucial factor in the search for life beyond Earth. This zone is the area around a star where conditions are just right, not too hot and not too cold for liquid water to exist on a planet's surface. Water is essential for life as we know it, so finding planets within this zone became a primary objective for exoplanet hunters. In the following years, astronomers refined their techniques and began to discover more and more exoplanets. The launch of space-based telescopes, such as the Kepler Space Telescope, revolutionized the field, allowing us to detect planets much smaller and farther away than ever before. Many of these new worlds were found within their star's habitable zone, sparking excitement and speculation about the possibility of life elsewhere in the universe. These pioneering efforts paved the way for a new era of exoplanet discovery. The quest for habitable worlds outside our solar system had truly begun, and with each new discovery we inch closer to answering the age-old question, are we alone in the universe? The search for exoplanets is akin to finding a needle in a cosmic haystack. And yet, with the aid of our cosmic magnifying glasses, our telescopes, we have been able to spot these elusive celestial bodies. Telescopes like the Kepler and the Hubble have been instrumental in this pursuit. These mighty tools of astronomy act as our eyes into the universe, capturing light from distant stars and galaxies. The Kepler Space Telescope in particular has an impressive track record. Launched in 2009, Kepler has discovered over 2,000 confirmed exoplanets. How does it achieve such a feat? The answer lies in the transit method of detecting exoplanets. Imagine you're observing a star, and suddenly its brightness dips a little, then returns to normal. This slight dimming could be an indication that a planet is passing in front of the star, blocking some of its light. This is known as a transit. Kepler continuously monitors the brightness of over 150,000 stars in a specific region of the sky, searching for these tiny dips in brightness. Each dip could potentially be an exoplanet transit. The Hubble Space Telescope also contributes to the hunt for exoplanets, although in a slightly different way. While Kepler is a planet finder, Hubble is more of a planet characterizer. It examines the atmospheres of exoplanets, providing insights into their chemical composition and potential habitability. These telescopes, along with ground-based observatories and future space-based telescopes, form the backbone of our exoplanet search. They are our cosmic detectives, tirelessly scanning the heavens for signs of other worlds. As we continue to refine these tools and develop new ones, our ability to detect and study exoplanets will only improve. We are gradually peeling back the layers of the universe, revealing the hidden wonders that lie within. These technological marvels have revolutionized our understanding of the universe and our place in it. They remind us that we are part of something much larger, a vast cosmic tapestry that is waiting to be explored. Discovering an exoplanet is just the first step. Once we have identified these distant worlds, we then embark on the intricate process of characterizing them. This involves studying their atmospheres, surface conditions, and other crucial factors that could hint at their habitability. It's like being a detective in the cosmos, piecing together the clues to solve the grand puzzle of life beyond Earth. Each exoplanet is unique and requires a tailored approach to analysis. We delve into its atmosphere, looking for signs of gases that could suggest the presence of life. Oxygen, for instance, is a key ingredient for life as we know it. Yet the detection of oxygen, or other gases like methane, doesn't guarantee the presence of life. These gases can also be produced by non-biological processes, adding another layer of complexity to our cosmic investigation. We don't stop at the atmosphere. The size and mass of an exoplanet are also critical, too small. And it might not hold onto an atmosphere capable of sustaining life. Too large, and its crushing atmosphere could make life as we know it impossible. We're searching for that sweet spot, a planet that's just the right size, with just the right conditions. The exoplanet's location in relation to its host star is another vital piece of the puzzle. If it's too close, the planet could be a blistering inferno. Too far, and it might be a frozen wasteland. We're looking for planets in the Goldilocks zone, where conditions are just right for liquid water to exist on the surface. As we continue this galactic hunt, each new discovery propels us forward, adding to our understanding of these distant worlds. Some may prove inhospitable, while others might just hold the potential for life. But the pursuit is far from over. Every new discovery brings us closer to potentially answering the age-old question of whether we are alone in the universe. It's a thrilling quest, one that fuels our curiosity and drives us to push the boundaries of our knowledge and technology. And with each passing day, we edge closer to deciphering the mysteries of the cosmos. The search for habitable exoplanets is an ongoing journey. A journey filled with anticipation, curiosity, and a relentless drive to answer one of humanity's most profound questions. Are we alone in the universe? As we delve deeper into the cosmos, the tools at our disposal are becoming increasingly sophisticated and powerful, opening up new avenues for exploration and discovery. The James Webb Space Telescope, or JWST, is one such tool. Outfitted with a suite of cutting-edge instruments, the JWST promises to revolutionize our understanding of exoplanets. Its unprecedented sensitivity and resolution will enable scientists to probe the atmospheres of distant worlds in exquisite detail. We'll be able to detect the faint signals of molecules that could hint at the presence of life. Molecules such as water vapor, carbon dioxide, and perhaps even the elusive oxygen. But the JWST is more than just a high-tech telescope. It's a symbol of what's to come in the field of exoplanet exploration. It represents a future where we're not just spotting exoplanets, but studying them in depth, characterizing their climates and assessing their habitability. Each new mission, each new telescope launched into the cosmos brings us one step closer to finding a world that might harbor life. And let's not forget about the excitement these missions generate. There's a palpable sense of anticipation as we wait for the next batch of data, the next announcement of a potentially habitable world. These missions captivate the public imagination, sparking discussions about space travel, alien life, and our place in the cosmos. As we look to the future, we can expect more missions like the JWST, missions that push the boundaries of what's possible, that take us further into the universe than ever before. Each one brings new hopes, new discoveries, and new possibilities. As we stand on the cusp of a new era in exoplanet exploration, the possibilities are as limitless as the universe itself. We may not know what the future holds, but one thing is certain: our journey is far from over. The search for habitable exoplanets continues, and who knows what exciting discoveries await us in the vastness of the cosmos. The search for habitable exoplanets is more than just a scientific pursuit. It's an existential journey that touches the very core of our being. It makes us question our place in the vast cosmos, pondering our solitary existence against the backdrop of a seemingly infinite universe. Could we be the only sentient beings in this grand cosmic theater? Or are we part of a larger interstellar community? Discovering habitable worlds could reshape our understanding of life itself. It might challenge our long-held beliefs and redefine our perception of what it means to be alive. It could reveal that life is not an earthly anomaly, but a universal phenomenon, as common as stars and galaxies. The possibility of finding life elsewhere stirs our imagination, fuels our curiosity, and drives our relentless quest for knowledge. It sparks countless works of science fiction, shaping our culture and our dreams of the future. Whether we find life out there or not, the search for habitable exoplanets will continue to inspire us, challenge us, and expand our horizons.